Okay, so this video is going to be briefly talking about what we call the zero product principle, right? And all that is that if I have any number multiplied by zero, then I'm going to get zero, right? So for example, if I say, m equals zero, right? So zero times n, it doesn't matter what n is, we're still going to get zero as our product, right? So the bigger implications there are in factoring and in quadratics, right? And later on, when we get into a higher degree polynomials, we can find roots using the zero product principle, assuming that those polynomials are factorable somehow. Okay, so let's kind of play with this. So let's look at this first example that I have here. So if I say that m is x minus 2, right? And then I say n is x plus 5. What values of x would make me be equal to 0? And that's pretty simple, right? Common sense tells me that 2 would make me be equal to 0, right? Because I would have 2 minus 2 and 0 times, well, it doesn't matter what happens over here. I'm still going to end up with 0. And same idea over here, I would say negative 5. Negative 5 plus 5, right? If I multiply that by, doesn't matter what x minus 2 is, right? This is going to be 0 times x minus 2, right? And actually, that would be negative 7. But anyway, negative 7 times 0 is still going to give me 0. Okay, so very simple what the zero product principle is. Let's look at another example real quick. Then we'll call it a day on this video. So now I'm saying, okay, let m be x plus 1. And let n be 2x minus 7. Oops. Okay, so left one, pretty obvious. We cannot have negative 1 or else we get a 0, right? Negative 1 plus 1 is going to give me 0. Doesn't matter what happens over here. 0 times anything is still going to give me 0, right? So I know one of my solutions is going to be negative 1. But what about my second solution? This one's not so obvious here. So what I might do is go ahead and set this individually equal to 0, and then just solve for x. So I add 7 to both sides, divide by 2 on both sides. Right, so you could say 7 over 2 or 3.5. The point is our other solution would be 7 halves or 3.5 if you like decimals. If I plug in either one of these for x, either here or here, right? If I plug in negative 1 here, or if I plug in 7 over 2 here, I'm going to arrive at 0. Okay, so that does it for this video. That's all the zero product principle is. Pretty simple stuff. And hopefully you can see what the implications are as it pertains to factoring and finding x-intercepts. Goodbye.